Welcome to the 7th video in an 8-video series on rational expressions, complex expressions. First of all, let me distinguish complex expressions from complex numbers. Complex numbers are a system of numbers that are used to deal with the square roots of negatives, and you may or may not know something about those. If you do and you recognize that word, I'd like to start by saying that that has nothing to do with what we mean by complex expressions. They're really more just complicated expressions where you have fractions inside of fractions. So I'm starting this video by declaring that this has nothing to do with complex numbers. Okay, that being said, before we do this first problem, I'd like to pose a different problem. I'm going to pause for a moment and let you work this out in your head. Hopefully, you decided to add and subtract before you did the division. Now, this is worth mentioning because addition and subtraction don't traditionally come before the division in the order of operations. But it's worth pointing out in this case they do, because the addition and subtraction are grouped within a single fraction. And so for that reason, we would do the addition and subtraction first here and then the division. Hopefully this was intuitive to you. Now, that's not the problem I want to do. This is. But it reminds us that in order to do this division problem, we're going to have to do the addition and subtraction first. In other words, we're going to simplify the numerator, then we're going to simplify the denominator, and then we can worry about the division after that. It's almost as if when you're given a complex expression, you want to treat the top and bottom as if they were two separate math problems. All right, it doesn't matter which one I start with, so we'll start with the numerator. Now, the way this video is designed, I will show the pause symbol, at which case you should pause, grab some scratch paper, and work along with the video. So you hit pause, work out the numerator, and then come back. Okay, here's my work. Hopefully you got 7/18. If you didn't, take some time to look it over, see if you made a mistake that's findable. All right, I've got my answer for my numerator. Now get ready to hit pause and get to your scratch paper again. We're now going to work out the denominator. So hit pause, work out the denominator. I'll wait. Okay, hopefully you got 1/4. If not, you can look over my work and your work and analyze all of that. Okay, so what I've done so far is I've worked out the numerator and denominator as if they were separate math problems, and I've substituted them back into the bigger fraction. Okay, now essentially all we have is a division problem. Well, the way we do a division problem is we turn it into a multiplication problem. If you've seen the previous videos, which I'm assuming you have, then this shouldn't sound strange. Notice I've just multiplied by the reciprocal of 1/4, which is 4/1. And now that I've turned this into a multiplication problem, I just can multiply using any means that I like. You could multiply straight across. 7 times 4 is 28. And 18 times 1 is 18, and then you could reduce 28/18. There's nothing wrong with that. My method is a little different. I like to do this the same way I do it in algebra, where I factor things. Now, it's kind of obvious why I factored 4 into 2 times 2. That's the only way you can factor it. But notice I factored 18 into 9 times 2. Could I also have factored 18 into 6 times 3? Well, I absolutely could have, But I chose 9 times 2 so I could pair up a couple of the 2's and make a unit fraction 2 over 2. And since 2 divided by 2 is 1, and 1 times anything is itself, I now have my final answer, which is better written as 14 over 9 rather than 7 times 2 over 9. Now this is probably not the kind of problem you would see in most algebra classes. Typically the problems in algebra classes have letters or variables in them. So here's an example of a problem with variables. Let's work this one out using the same strategy. First we're going to simplify the numerator, then we're going to simplify the denominator, and then we'll make a single fraction out of those simplifications. All right, numerator first. Get ready to hit pause. When you are ready, hit pause and work out the numerator on scratch paper as if it were a separate problem. Go ahead and hit pause. Okay, hopefully this resembles the work that you showed, and hopefully you got the same result for the numerator as I did. If not, take a moment and pause again and analyze all of the work. There's our numerator. Now we're going to move on to the denominator of the original problem. Get ready to hit pause again. In a minute, you're going to hit pause and work out the denominator, and then you can compare your work to mine. Go ahead and hit pause. All right, hopefully you got 6 plus x all over 3x, and that's our result for our denominator. And I'll carry us through the rest of the problem here. Now that we've worked out the numerator and denominator as if they were separate, unrelated math problems, I now have a single fraction over a single fraction. I can now use the reciprocal rule by flipping over the bottom fraction and turning it into a multiplication problem. Now, if you've seen previous videos, and I'm assuming you have, the way we multiply rational expressions like this is we factor and then interchange the factors to simplify. So first of all, here's the factorization. And one thing worth noting here is that I factored 9x squared into 3x times 3x. Now these monomials are a little tricky because I wouldn't always factor 9x squared into 3x times 3x. Sometimes I would factor it into 9x times x, or maybe wouldn't factor it at all. So what I like to do with monomials is I like to think ahead about how and if I want to factor them. Because unlike other polynomials, monomials have multiple factorizations. And so the reason I chose 3x times 3x in this case is because I wanted at least one 3x that I could pair up with the 3x in the numerator. That made the other factor be 3x as well, so that was my rationale. And now that I've factored everything, I can rearrange my factors. Notice this is simply a rearrangement of order and doesn't affect the value of the expression. It's mathematically equivalent. But notice, the two fractions on the right, 3x over 3x, and 6 plus x over 6 plus x, both have a value of 1. And of course, 1 times anything being itself leads me to my final answer. Let's look at one more complex expression. We're going to run through the same set of concepts here. We're going to simplify the numerator, then we're going to simplify the denominator, again as if they were separate problems. In a minute I'll have you hit pause and do some of the work. Okay, here's the numerator. We're going to work that out. Go ahead and hit pause. Now compare your work to mine. If you got a different answer, try to find out why. Moving on, there's our numerator. Moving on to the denominator. Get ready once again. In a minute, you're going to hit pause and work that out as if that were its own math problem. Go ahead and hit pause. Here's my work. Go ahead and compare it to yours. That's the answer for my denominator. And now, notice, I have finished working out the numerator and the denominator as if they were their own separate math problems, and now I'm ready to do the division. Well, as usual, division requires the reciprocal rule, so there's me flipping over the bottom, as it were, and now I've turned my division problem into a multiplication, and as usual, we multiply by interchanging factors. But before you can interchange the order of the factors, you have to have everything factored. Notice there's one thing in this expression that's not factored, and that's the x squared plus 11x minus 60. Well, it took me a minute to factor that myself, but I eventually, through guess and check, realized that it did factor. And now that I have all the factors, if I rearrange them, pairing like factors into their own single unit fractions, and I say unit fraction meaning a fraction whose value is 1, then that greatly simplifies the problem. Again, notice this is purely a rearrangement. I haven't done any other mathematics here other than rearranging the order in a clever way, because now, looking at the bottom line here, my two fractions on the right both have a value of 1, and of course 1 times anything being itself leads me to my final answer. Okay, here's a brief summary of the concepts. You'll be given an expression with pluses or minuses in it, rational expressions on top and bottom. You will do some algebra to simplify the numerator, get a single fraction answer. You'll do some algebra to simplify the denominator, get a single fraction answer. You'll then divide those answers using the reciprocal rule, and by interchanging factors, it will lead you to your final simplified answer. And that completes the 7th of 8 videos in this series.